Alright, and here what we're going to be doing is going through the axle peg. It's the same principle that to make it as we were using for the hitch peg. We're going to be drawing half of it and then revolving it. The only difference is that we have some threads on here as well as the hex head, so that we could actually tighten it down in there. So what we're going to do is open up a new file, create another 2D sketch, and I'm going to go ahead and draw that out. So I have my overall axis line. Okay, worry about the arch later. We'll worry about that chamfer in a sec too. But we're going to start with that. And now what I can do is go ahead and start dimensioning it. Now, if you notice here that it says that it's a 1/4 inch, 1/4 inch 20, so that basically is talking about the thread. It also gives me the size of the shank as well. So I have 1 inch. If you remember from Woods 1, or if you've taken Woods 1, that when you measure a bolt, or a screw, it's measured from the bottom point to the underside of the head. So this means that from this end point here to the underside of that head is 1 inch. So I'm going to dimension from there to here, 1 inch. And then I had the diameter, which was 1/4 inch, so half of that is 1/8 inch, or 0.125. Okay. And here it gives me the diameter of 0.422. So again, that's the diameter, and we're only dealing with the radius. So I need to do half of that, so 0.422, either divided by 2 or just type in 211. So divided by 2. That brings that in there. Then from here you can see that it says it's 0.031 for that thickness, that little lip right there. So 0.031, dimension that. And then I have my, I can go ahead and I can draw this flat in right now. And what that is, it's saying that the diameter of this is 1/4 inch. So I can draw a line up here, this end point, and that was, diameter was 1/4 inch. So radius is 1/8 of an inch. And from the next step that I can do is, again, dealing with the spherical radius. So what I can do is take my arch, 3-point arch, those are my 2 endpoints, and it had a radius of 0.236, so 0.236, and that should drop that in. It's not letting me. Okay. What I have to do is dimension from the underside of this head to the top side here. So I missed that dimension. But what you're going to do is dimension from, like I said, the underside of that head to the very top, and that is 0.125. Okay, so here, 0.125. Now it's starting to look a little bit more as it should in real life. Okay, so 3-point arch then again, here, here, and this is where I'm going to want to type in. I don't want to have it tangent like how I did most times before, but I'm going to type in that point, what was it, 0.236, 0.236, and that should give me that spherical radius. Okay, so from there what I can do is go ahead and revolve it. Finish my sketch. It's already found the profile. Now it's asking for what axis. It's going to be that center one. Here what I'm going to do is I'll chamfer it. Okay, so it needs a 45-degree chamfer with a measurement of 0.03. Okay, so it's asking what edge do I want, and what I'm going to do is I'm going to select this second tab right here, because it says what tab do I want and what distance do I want it at. So I want it at 45 degrees at 0.03. Yes, 0.03, 45 degrees. What face is it looking for? Okay, so right there. And what edge do you want it to be chamfered? And that's this one right here. I guess, yeah, you could technically just do this one. It does the same thing. It's going to go in at both measurements, so it means that from this line here to this line here is 0.3, and then so height-wise it's 0.03, and then width-wise from this endpoint over horizontally is 0.03. So either one does work, but if you have a chamfer with a different degree, you can do that as well. So select that edge and hit apply. Alright, so the next step that we want to do is we can actually end up putting our thread on there. Okay, and notice how it's offset 1/4 of an inch. Okay, so those threads don't go all the way to the top because it's going to be going through, like the name implies, the axle peg, so it's going to be going through this hole. So we don't need threads running through this part of the wheel because we want it to spin freely, just like a bearing. So I'm going to use thread, select my surface. I don't want the full length, so I want it offset like we said, 0.25. Notice how it's offsetting from the very bottom, so I want to flip that. Okay, and what is the length? So from there I have to go the overall length was 1 inch that we said. The offset was 1/4, so 1 inch minus 1/4 is 0.75, and that is, hold on a second, it's coming from the wrong offset. So length 0.75, and what I want to do is offset that 1/4, 0.25, right there. Okay. So I kind of got that figured. So it might be you have to type in your length, so 3/4 of an inch, the overall length, and then type in your offset, which is 1/4 of an inch. Okay, so go ahead and hit apply. Next, what we want to do is create our socket for the Allen wrench to go in. And what we're going to do is create a 2D sketch on that flat surface up top. Now we could end up drawing a hexagon, trying to get it all dimensioned out, dimensioning the angles, but we have this polygon tool up here. It makes it nice and easy. So I'm just going to select how many sides I want. So hexagon has 6, so I'm going to create that. And I guess it doesn't necessarily matter which way it goes. You can try and get it lined up, that's fine. If it's at something like this, because remember that the screw will be turning, so it doesn't necessarily matter. So we'll place it like this, okay, and then we have it's across the flats is 5/32, so that means from this flat to that flat is 5/32. Dimension from this flat to that flat, 5/32. That bumps that out. Finish my 2D sketch, and it said it's a depth of 0.111 deep. So I'm going to extrude, zoom in, find my surface. Okay, so that's my surface. Again, I want to make a cut, and 0.111 inches deep. Hit OK, and again, just change my material. And from there, you can go ahead and save that, and then move on to your next one.